Alright, then we have more people now in the room, so it was like a good discussion. Alright. Okay. So, my name is Anuva Ambastha, and I am from Red Hat Global Partner Enablement Team. And in my current profile as a solution architect, I help and focus on key SI partners for Red Hat and help them deliver meaningful solutions using Red Hat products. Even if they are new to Red Hat, they have not explored all the newer offerings from Red Hat into a large extensive project. So today our topic of discussion is delivering DevOps with the next generation of PaaS. And before I begin, I would like to ask a question. Have you ever wondered why DevOps is getting so much of attention these days? Why there is such a buzz about DevOps? The answer is very simple. It is because DevOps is solving one of the biggest business concerns of our generation. That is, how do organizations, IT organizations, move from being good to being great? Software and cloud technologies are causing disruption across the industry. So whatever vertical you are in, if you are in retail, you are talking about Amazon, if we are talking about media, Spotify, Netflix, are classic examples. If you talk about transport vertical, Uber is another example. So you see, forever, consumers are looking for newer solutions. They are picking up new solutions from vendors, and these vendors, these competitive vendors are using technology, using newer technologies to deliver and drive greater value proposition to their customer. The traditional IT, before that, there was a study among the CEOs of large organizations, and more than half of them felt that their next biggest competitor is not going to be a pure play offering, but it is going to be a software-driven competition, which is going to disrupt the way they have been doing things in recent past. So traditional IT actually has not been able to keep pace with this change in environment, in this change in demand for personalized service, with changing landscape, changing technology trends, and the competitive landscape. Under this slide, let us see what DevOps really is. So what DevOps really is, you will see the definition on your screen. As you go through there, you will realize that DevOps is an extension. It is an extension of Agile software delivery technology. Agile software delivery technology prescribes a very close collaboration between consumers, between product development team, between developers, and sometimes QA, to rapidly iterate, to find out the gaps and rapidly iterate towards a better product. So in a way, DevOps is extending the Agile technologies from just to the code to the entire delivery cycle, entire delivery process. And since DevOps is a new way of doing operation, you can consider DevOps as a disruptive innovation. It is literally a mindset, a set of tools, and a set of process which is disrupting the classic model of operation and its paradigm. Here we talk as to, is DevOps for everyone? Actually, DevOps can be right for every organization, provided you have done a due deliberation, you have done due introspection of the skills and resources you have. To be more precise, It may not be right for every organization unless you have done or you have a deep understanding of the foundation of your resources, of your skills, what you want to achieve and how you want to achieve. Furthermore, it is not about a particular product or a particular tool. In your DevOps lifecycle, you are going to use multiple products. You are going to use many tools. Just by using one tool, you cannot think that you are doing DevOps. Or one particular tool can magically take you from waterfall to classic DevOps. It is more than automation. Just because you are using continuous integration or continuous delivery, you are using CI or CD, it doesn't mean that you are following the DevOps process or you are DevOps. It will be one of the steps, but not the only step. So who all would be involved in this entire iterative process in which we iterate towards a better product? It is no longer in the DevOps world, it is no longer going to be us versus them, this department versus that department. We are looking about collaboration, we are looking about better interaction between the teams. And one of the most important teams which will be into this will be the development team. They are the ones in the classic model suffers the most. They spend months and hours together in trying to figure out the requirement phase, and then to toss it over because the times have changed, the requirements have changed, the technology changed, or trends have changed, or the consumer desires something else. The next in line would be the operation. Any increase in operation, any increase in productivity will lead to increase in productivity. Increase in productivity is going to lead to increase in profitability, increase in market share. So operations is another team which is very classically involved in DevOps. And lastly, the QA team. The QA team, due to its positioning between the development and the operation team, is now no longer considered to be a fault finding or a bug finding team. They have moved beyond it. They are not a defect finding, but a defect avoiding team. Because of their position between the devs, they will help you. They are in a classic position because they push the product to deployment. They can also roll it back. So they are no longer to be considered as a bug finding or a defect finding, but a defect avoiding team. So this is the classic scenario how things are in traditional world. The moment there is a direction from the leadership, the two teams take their work and move into their siloed corners. The development team has its own set of concerns and operation team has its own set of concerns, and there is no interaction, no collaboration between the teams. And in course of this action, if there are some issues which come up, then it is going to be either the problem with the ops team or it is a problem with the code, because the lack of any collaboration and interaction. Now, this siloed behavior of the teams, this siloed, moving to different corners, actually can be considered to be the core driver behind DevOps. It is because of this problem, this siloed behavior has created a big problem into the industry. And this siloed behavior can be considered the core driver behind DevOps. And by DevOps, we are attempting to have better collaboration, to remove this silos behavior, and with this better collaboration comes agility, comes efficiency, and the speed by which we are going to deliver the product to the market. The greater agility means the speed how we deliver the product to the market. In the classic, so till this discussion we had, you would have realized that DevOps is largely about collaboration. It's not a very complex concept. It is about meeting, mixing with people. It is about collaboration between dev and operation teams. And this classic and this DevOps environment, life cycle, can be summed up by this acronym called CAMS. Okay? Each letter of this model, this CAMS model, represents a pillar in a successful DevOps implementation. Each letter. So when we talk about C, culture, what would culture implement? Culture talks about own the change, drive the change. Drive the change for collaboration between DevOps, between development and operation teams. Break down the walls between two teams so that there is free flow of exchanges, free flow of ideas, free flow of thoughts among these teams, and thereby we eliminate the siloed corners what we had in software development. Okay. Automation. Automation, do away with all the manual tasks into your process flow. When you do away with your manual task, you are going to reduce human errors. The more automation you have, you will free up your skilled resource. You will have more resources. You know, the ops team would be more free to do other activities. You are automating most of the processes. Now there are a lot of automation tools which are already available. You have tools for configuration management, you have tools for provisioning, you have tools and tools. And all these tools are going to together stitch your DevOps automation fabric. Okay? So the more tools you use, more of your ops teams are able to automate their task. You are having a speed and agility to deliver software products faster. When we talk about L, that represents lean. Have a lean development cycle. The lean totally remove the waste. And by having this lean development cycle, you are going to iterate. You are going to iterate over faster productivity. When we talk about metrics, in a DevOps world, you need to measure, gather metrics as much as you can, as often as you can. Because if you cannot measure it, you cannot improve it. So the more metrics you can gather metrics from everywhere. You can gather metrics from your business operation, like what is the number of orders, what is the revenue you have generated. You can gather metrics from operations, like what is the number of incidents you had. You can even gather metrics from your technology side, like what is the root cause analysis you could do. So there are a whole lot of metrics, and you have to gather this metric as much and as often as you can, and analyze this and use this data to improve into your development cycle. Lastly, you have sharing. Successful or not, share the knowledge, because with each knowledge sharing, the teams learn. You at least learn not to repeat the same mistake again, successful or not. So learning and sharing is very important in a DevOps world. So all these pillars, what you have seen, all these 5 components, as I have told you earlier, are the pillars of a successful DevOps implementation. And if you compromise with any one of them, you are going to compromise with the DevOps delivery, the DevOps implementation into your organization. Now this slide talks about the DevOps workflow. How does the workflow in the DevOps world? Now here we have 3 major components. One is the ops team. The ops team is thinking about how do we create the environment, create the development environment, whether it is going to be an IaaS-based environment or it is going to be a platform as a service environment. How do I create this containerized environment? On the other hand, the dev team is more focused on whether the development has to be done locally on our local machine, or do we need to work it on cloud? How do I create a microservices-based cluster? How do I deploy it? How do I have continuous integration and continuous delivery into my organization? And the PaaS runtime is all about scheduling, orchestrating, and deploying the application. It also is concerned with monitoring and analyzing it. And all this data with the monitoring and analyzing, you would have realized by now that DevOps is a closed loop feedback cycle. So when the PaaS runtime gathers information, it feeds it back into the operation team, feeds it back into the dev team, so that they can analyze the data, they can understand the data, and improve the solution.
All right, thank you, Anuva. I appreciate it. My name is Jeff Brad, and I'm part of Anuva's team, enabling partners, among other responsibilities that we have. This is my second week in India, where I've had a very enjoyable time, so I'm going to pick up where Anuva left off. She was talking about DevOps and how IT is looking to become more responsive and more agile. And we're looking to do that by a closer collaboration between the development team, the operations team, the QA team. So from a technical perspective now, wouldn't it be nice if all three of those teams would be able to optimize their own internal processes around a single common interface, a single common API? And it just so happens that in the last few years, there has been a technology where it seems to be turning out to be that common language and API where all three of those organizations of an IT department can optimize their own processes. And that technical implementation happens to be called Linux containers. And so this is a technology that's been kind of in the works, or at least bits and pieces, for the last 10 years or so. And so where does Red Hat fit into this? So the first thing is, Red Hat happens to know a little bit about Linux to begin with. And specifically to Linux containers, we've been in this business for a long time. If you look at the components of Linux containers, namespaces, SE Linux, C groups, right? These are technologies that Red Hat's been involved in for a long time. Linux containers is at the heart of what's known as a platform as a service. And the implementation, the product that Red Hat provides as a platform as a service is called OpenShift Enterprise. Okay, so a couple of things about OpenShift Enterprise real quick. We're running a little bit out of time. The first part is a little bit what I was mentioning. It is standards. It's a standard container API. So it's the API that all three of the IT organizations can collaborate on from a technical perspective. Now, in the community, there has been a specific implementation of Linux containers that seems to be becoming more and more popular. And that specific implementation of Linux containers is called Docker, right? And so Red Hat has been very supportive of the Docker, more so than just even Linux containers, has been specifically supportive of the Docker initiative, collaborating with Docker, the organization, QA and providing commits to that project. So from a Linux container perspective, Docker is the implementation that we use as the basis of OpenShift Enterprise 3, which is our latest version. Came out at Red Hat Summit about April or May of this past year. Let's talk about web scale container orchestration and management. This is the tricky part of a platform as a service, the ability to orchestrate at the runtime those Dockerized Linux containers. And so, similar to Docker and how there's an implementation of Linux containers, and it's an open source community called Docker, there is an equivalent open source community called Kubernetes that's responsible for orchestration. Originally started from Google. Red Hat is collaborating with Google, and we've got part of our development team committing to that project. Kubernetes is the orchestration engine found in OpenShift 3. And the other thing I want to talk about is a large selection of supported application runtimes and services. So this is particularly important for me as a developer. Yes, as a developer, I have agreed that my deliverable is a Linux container, and in particular, a Docker container, right? But I still want, as a developer, the freedom to be able to choose the programming language that is most best suited for the business need and is a programming language that I'm comfortable in. So a platform as a service needs to have and allow for a wide breadth of programming languages that developers can begin developing their software solutions on. And so that's what you see in OpenShift Enterprise, is this large variety of programming languages to get programmers started and proficient. All right, so much like any other Red Hat product, there is an upstream community project where all of our innovation happens. And so that's what you see with OpenShift in particular. We have an upstream community project called OpenShift Origin. It's up on GitHub. And this is where our own engineers are making commits to. In addition, we're also pulling from even further upstream community projects like the ones I mentioned, Docker and Kubernetes. We pull in those changes from those community projects, and then we add a lot of QA, we add our support teams, we add our documentation teams, and the output of that is our supported products. From the top, we have OpenShift Enterprise. This is the product that you can purchase a subscription for if you're looking for a platform as a service, either on-premise or in the cloud. You will own the bits. You will own the OpenShift Enterprise environment and experience, and your operations team will manage that. We have OpenShift Online, which is more of a software as a service offering, whereas myself as a developer, I can navigate my browser to OpenShift Online, create an account, and literally in a few clicks of a button, I'm off and running, developing in my programming language of choice. And then OpenShift Dedicated is a newer offering where you still want the benefits of OpenShift Enterprise in terms of owning that dedicated slice of the PaaS, but you also want to lean on the experience and expertise of the Red Hat operations team to manage it for you. Now this slide, real quick, what I want to mention is that being that we're working with Linux containers, right? If you have an application or a service that you want to run in the PaaS, the bottom line is that it needs to be able to be Dockerized. You need to be able to wrap it as a Linux container. And being that that's the foundation of OpenShift Enterprise, you can imagine this opens up a huge realm of possible applications and services that can run as a first-class citizen in your OpenShift platform as a service. And so Red Hat has a large variety of containers that already run and are supported in OpenShift Enterprise. These are our mobile offerings, our JBoss EAP offering, integration services, VPN, so on and so forth. And then also, if you're an ISV looking to run and sell your container, your services on OpenShift Enterprise, if you can containerize it as Docker, then it's going to run as a first-class citizen in OpenShift Enterprise. Okay, folks, we're running out of time, so I'm going to stop here and real quick open the floor to just a couple of questions if anybody has any.
DevOps does the role of developer gets in or the operation role gets in?
The question was, in DevOps, do the roles of the development team or the operations team necessarily change? The answer is not really, in my experience. You still have a development team, you still have an operations team, but the difference is that they're working more closely together. And they've decided to standardize as that interface between the two of them, Linux containers in particular. Another question? Okay, thank you very much, appreciate it.